Okay, let's take a look at 3.5. So in 3.5, we're going to actually change what we've been doing kind of in reverse right now. So up to this point, we've always been using the fact that two lines are parallel to prove information about a particular pair of angles, whether they're alternate interior, alternate exterior, consecutive, corresponding. Each of those we had a relationship that we built over the last few sections. So what we're going to do now is we're actually going to change the game and we're going to use information about angles to prove something about the two lines themselves. So let's say we had two lines, M and N, right, cut by a transversal we'll call T here, and we knew that these two angles are congruent. All right, those are two corresponding angles. So what that's actually going to give us is it's going to give us that the two lines M and N are parallel. All right, so this really makes it an if and only if statement. All right, we already knew that if lines were parallel, corresponding angles were congruent. This actually flips that and says if corresponding angles are congruent, then we have parallel. All right, our abbreviation for this rule is going to be corresponding angles congruent, a little bit of shorthand, imply parallel lines. All right, because if two lines in a plane are cut by a transversal so that corresponding angles are congruent, then the two lines are parallel. All right, and that's a postulate, so that's something we're going to take kind of for granted, and we're going to use that to prove some of the other theorems and converses that we see coming up. Now, another postulate that's really important actually in the geometry we work with. It's actually one of the foundational ones, and if this isn't true, then we're not on a plane, and a lot of the geometry we work with actually falls apart. So if you're working on a sphere, this may not hold true. And what this says is if there is a line, so I'll call this line L, and a point not on the line, point P. All right. This postulate says then there is one line through P that is parallel to L. All right. So there's only one option through P that is parallel to L. All right, we don't really have an abbreviation for this one. It doesn't get used in a lot of proofs, but what this does is it actually forces us onto a plane surface, which really makes all of our Euclidean, the fancy name for the geometry we study, stick together and hold. As soon as you go on a different surface, like a sphere, again, that postulate may not hold true like it does on a plane. Now, a couple of the converses that we get from what we've been doing last week, they all hinge off that first postulate we had, which was that corresponding angles congruent implies parallel. So this one's talking about alternate exterior angles. So I have two lines again, M and N, right? But this time we know alternate exterior angles are congruent. I'm going to number those 1, 2, and 3. All right, we know 1 and 3 are congruent, but from vertical angles we could say 2 and 3 are congruent. And as soon as I do that, now I can say 1 and 2 are congruent. If 1 and 2 are congruent, we have corresponding angles congruent, which we know from that first postulate implies parallel. All right, which means that we're going to have the situation that if we have alternate exterior angles congruent, then the two lines are parallel. So our abbreviation, alternate exterior angles congruent, implies parallel. All right, and that's just a reverse of a rule that we've been using a lot throughout the first few sections. So the next one says alternate interior angles. So now I have two lines, M and N. All right, so M and N, and I have a transversal come through. And this time they talk about alternate interior angles. All right, and I'm going to call these angles 1, 2, and 3 again. And if 2 and 3 are congruent, we know 1 and 2 are congruent by vertical. So 1 and 3 would be congruent, which is corresponding angles. So again, we can draw the conclusion M is parallel to N. So we'll say then the two lines are parallel. All right, and our abbreviation here, alternate interior angles congruent imply, all right, parallel lines. And again, some of these shorthand little abbreviations we're going to use to make writing a proof or an argument much quicker because it gives us a quick line to use for the reason for one of our steps. Now the next one starts talking about consecutive angles. So this one says consecutive interior angle converse. So I'm going to go ahead and draw two lines in a transversal. All right, I'll call it M, N, and T. All right. And this time they say something about angle 1 and 2 here. All right, what they say is measure of angle 1 plus measure of angle 2 equals 180. All right. So those two are supplementary. Now, for those two to be supplementary, all right, there's a lot of ways we can work with this one. What I would like to think of is I'm going to actually think about 3 here. All right, if I put a 3 in that angle, 1 and 3 are supplementary as well. So 1 and 2 are supplementary, 1 and 3 are supplementary. All right, that means that 2 and 3 really have to be the same size. And that gives me corresponding angles, and if corresponding angles are congruent, we know we get the result of parallel lines. All right, so we can use that to say that if in a plane, two lines cut by a transversal, pair of consecutive interior angles is supplementary, then the lines are parallel. All right, abbreviation we'll typically use for this one is consecutive interior angles supplementary, and we'll just use SUPP for that, imply parallel. All right, now the next one is actually just like a slight extension off of the corresponding angles one. This deals with perpendicular. So now it says that you have two lines, all right, that are both perpendicular to the same line. All right, we know that perpendicular means they intersect to form four 90-degree angles. And if that's true, all right, then we can pick any one of these and call them corresponding angles. And we know if two angles are corresponding and incongruent, then that means the two lines that form them are going to be parallel to each other. All right, so then we're going to say then the two lines are parallel. And the way that we're going to abbreviate this one is kind of weird. We used one similar to this in an earlier section, but we're going to say perpendicular, and perpendicular implies parallel. So if you have a line perpendicular to a transversal, another line perpendicular to the transversal, then those two lines are parallel to each other. All right, so that's a quick summary of the rules that we're going to use when we start doing these examples. So if we look at the first one, we've got which lines are parallel. So first thing I need to do is I need to fill out the rest of the angles in this situation, and I can't go under the assumption that things are parallel just kind of out of the blue. So first thing I'm going to do is I'm going to run through and I'm going to fill in information, see if I have anything to help me out. All right, one thing that I know for sure is I know here that 63 plus 117 is 180. All right, so I have consecutive interior angles supplementary, which means that M and K, all right, are definitely parallel to each other. All right, so I'm going to say M parallel to K. All right, that's a certainty because I have consecutive interior. Now, that's going to allow me to draw some information from that top section to the bottom. So I'm going to fill in my corresponding angles, so I can put a 63 degrees here. All right, I can put a 117 here. Now, I'm going to use either alternate interior, alternate exterior, or vertical angles, either way you want to think about it. But I'm going to bring a 63 there and a 117 there, a 117 here, and a 63 here. All right, now, at this point, that's a lot of what I can do there. I'm going to go over to the other side now, and I still have M and K are parallel to each other. So that 80, I can bring down where the 9 is. All right, I know that vertical angle, so I can bring an 80 over there and an 80 over here. And then 6, 5, 7, and 10 all have to be 100 because I can form a linear pair, which is supplementary. All right, so we can fill those in. Now, again, notice I'm working off the diagram, and then I'm going to come back in. I'm going to backfill in the answers. Sometimes if you try and follow their order of questions, it's actually going to be more confusing than if you just go off the diagram and kind of piece through what you know. It's going to open you up to be able to get more of them correct in most cases. So I'll go ahead and copy those in. So we've got 80, 100, 100. 7 is another 100. 8 is 80. 9 is 80. 10 is 100. 11 is 63, 12 is 117, and then 13 is 117 as well. So we can fill those in as we go around. All right, I'll be back in the next video to run through the next couple.